So let's have a go at solving some differential equations. We're going to start with first order linear, so order 1, degree 1. And we're going to do the first type we're going to do is simply by direct integration. Now this only works for the case where the derivative is equal to some function of x. So dy by dx equals a function of x, which means that we can directly integrate both sides. If we integrate the dy by dx, we just get y, and if we integrate the function of x, we just get the integral of the function of x. So this is basically what I did for the two previous examples that we were playing around with. So here's an example. So dy by dx equals 3 sine x. So if we integrate both sides of this thing, we end up with y equals, and if we integrate sine 3x, we end up with minus 1/3 cos 3x plus c. Okay, so that's the general solution. So that's the answer to part A. So if we now have a look at part B, we're trying to say what happens when x equals 0 and y equals 0. So when x equals 0 and y equals 0, so we put x and y both equal to 0 into this thing here, we get 0 equals minus 1/3 of the cosine of 0 plus c. Well, the cosine of 0 is 1, so that implies that c has to equal 1/3. So the particular solution that we're interested in is y equals minus 1/3 cos 3x, and plus c is going to be plus 1/3 as the particular solution that we're interested in. And let's have a look with the boundary condition here. So now we're going to play around with the boundary condition. So when x equals pi over 2 and y equals 1, same thing, we just pop the x and y back into our general solution. So 1 equals minus 1/3 of cosine 3 lots of pi upon 2 is 3 pi upon 2 plus c, and the cosine of 3 pi upon 2 is 0, which just means that c must equal 1. And so in this case, the particular solution that we're interested in is y equals minus 1/3 cos 3x plus 1. Okay, so that's a reasonably simple example because you can just integrate the function we were given directly and then substitute our values in to find the particular solutions. But that's the basic process we're going to go through with differential equations, is solve them for the general solution and then use the initial boundary conditions to find the particular solution we're interested in.